Alrighty, so this is going on page 29 when we're done. Today we're going to talk about critical points and increasing and decreasing. All right, so your critical points over here are points where the graph changes its direction or shape. Okay, so direction or shape. And the extrema, so just a different form of the word extreme, are points where the graph changes what? Is that direction or shape? Direction. Okay, so the function has a minimum or a maximum value, relative or absolute, at these points. So if I'm going this direction, I hit the maximum and I'm changing my direction. So that's your change of direction there. And then point of inflection is where the graph changes what? Shape. There you go, the other one. So here, once I hit this point of inflection, the shape changes, but I don't change my direction. Still going in the same direction. You just have that little bump there. Okay. So we have relative and absolute. The relative can also be called local max and mins. If you have a point with the greatest value compared to the points around it, so it's a comparative type thing, this is your relative maximum. Right. Could also be called a local maximum. And then the point where the greatest value over the entire domain of the function would be the absolute. So when you're doing relative max, you're looking at just part of the domain. So if we went from like -10 to 0, this would be the relative max because it's the maximum in that interval. But overall for the function, here's my absolute maximum. Okay. This picture down here on this one, is there a relative maximum? No. Does one exist anywhere? Right here, would this be a relative maximum? Yes. Is there an absolute maximum? No. Okay. Because the greatest y value would be infinity, which really isn't a value. So there isn't a maximum. Okay. Infinity doesn't count. We don't use it for our numbers, so there isn't one at all. Okay. Good. All right. So then a point with the least value compared to the points around it would be your relative what? Minimum. And then the point with the least value over the entire domain would be your absolute. Okay. So your examples, and then again, if you feel like the absolute minimum is infinity, the answer is actually none. Okay, then there isn't one because that doesn't make sense. Okay, any questions? Awesome. All right, so down here this says, give the coordinates and classify the extrema for the graph of each function. Then it says, actually, use your graphing calculator to approximate if needed. No, so we mark that out because that's just whether or not you can push some buttons and you don't even know what the heck you're looking at. Right now we're just identifying them from the graph, from the picture itself, because in order to identify them algebraically, that requires calculus that I'm not going to teach you because this is not a calculus class. So you eventually will get there. You'll talk about all of these same points and more of what they do. Right now, our job is just to make sure that we all know how to find them, what they're called, and what happens at those points, and then how to find them algebraically comes later. So we're going to do a couple of things here that are going to make you feel a little bit like a rebel because we're not supposed to guess about points off the graph, right? Like if there wasn't an equation here at all, then I couldn't even be sure that this one was at the whole numbers. Like it looks like it, but it could be a little bit off, right? And then on over here, we're going to estimate, okay? Because yes, we could find it a lot more clear on the calculator, but that just takes time that is not necessary because that's not how you'd be finding it anyway. So we're just going to estimate them, and we're also going to use decimals, which is also going to make you feel a little bit like a rebel when you're doing that, but it's all good. All right, so when you look on number 1 here, this point right here, Is that a maximum or a minimum? Minimum. Is it absolute or relative? Absolute. All right, so that ordered pair is 4, what? -5. Now, because that's actually the vertex of that parabola, that's something that you are capable of finding algebraically, but for the other ones, you don't have those skills yet. And so this is an absolute min. Right. So on number 2, how many critical points do I have? Yeah, I actually have 3. I have one right here, one right here, and one right here. And when we estimate, we're just going to estimate to the 0.5. We're not going to worry about whether maybe it's 0.25 or it's all fine. So we'll start with this one. We'll say that's like -1.5, what, 3? And is that relative or absolute? Absolute. And it would be an absolute what? Maximum. Okay. All right, so then this point right here, that would be what, like 0.5? And then negative, what? 2, 3, 4.5? And what is that going to be? A relative min. Good. All right. And then the next one we'll say is 1.5. Then what? 2.5? Yeah, maybe 2.3. We're just going to go with 0.5. We don't have to worry about it. And that would be a what? Relative what? Max. Okay, max. That's what you meant, right? All right, we all good? All right, easy enough. All righty, so number 3. How many critical points do we have? 2. Okay. So this one here we'll say is it what? -3. Then what? -5. Okay. Is that relative or absolute? Relative. So this would be a relative min. This point, let's say it's -0.5 and then 4.5. And what's this going to be? A relative max. Okay, she's going to have to watch the video and catch up later, so you need to keep with us. Okay. All right. Number 4. Now the directions actually say find the extrema, but really what it should say is the critical points. So how many critical points does this have? There are 3 critical points. We got one right here, and so there's your relative max, your relative min, and then we have this one right here. Okay. So this point is what, like -1.5, what? 3, 6? Do you agree with that? Okay, make sure I'm counting right. And so this is a relative max. This point right here, we'll go jump to this one. This one is 1.50. Okay, good. And what would we say that one is? Relative min. All right. So then this one right here, which is at 0.3, what is that? Point of inflection. Very good. This is your point of inflection. So you've talked about max and mins and increasing, decreasing, but I don't think algebraically you've talked about concavity, like concave up, concave down. You should understand the concept of concavity from at least your science classes, but if you have a parabola that opens up, it's concave up. If you have a parabola that opens down, it's concave down, right? And then what happens with the point of inflection, that's where the concavity changes. So if you think about like the parent function of a cubic, looks like this, right? So if I took the left-hand side of a cubic and I reflected it up, it'd look like a parabola, right? So this right here is your point of inflection. So from here to here, it's concave up, right? And then when you hit that point of inflection, it's concave down. But it's still going the same direction the whole time. Does that make sense to you? So this doesn't, there's not a max or a min here, it's just a point of inflection. So it's not an extrema, but it is one of our critical points. That again, you'll focus on more later, like the real importance, what do you do with it? But right now we just have to be able to identify them. That's also going to help us when we're sketching graphs later, understand what happens at that point of inflection, that you get the little like squiggly there so that we can get our graph sketched right. Okay, we all good? I'll take that as a yes. Okay, increasing and decreasing. So moving left to right, a function may increase, decrease, or remain constant on certain intervals. This is not a difficult concept. Where the mistakes come in sometimes is that you get confused as to what to write, or even if you're not confused, you still write the wrong thing, because that's possible too. But you have to understand that what we're looking at is what, as x increases, what happens to y. And what you're writing down are intervals of the domain. So we're writing the x's, but we're talking about the y's, kind of is what's happening here. So when we look at this, I think you can look at that graph and you understand the increasing, decreasing, that sort of stuff. But as x increases, so as I come along the x-axis and x gets bigger and bigger, I'm looking at what happens with the y's. Well, right here, the y's are doing what? Increasing, right? So I start way out here at negative infinity, and this graph increases all the way to what? Negative 1, right? Now, we never include our infinities, right? Oh, negative 1, sorry. Do we include negative 1? Yes? No? Maybe? All right, I'm going to leave it open for just a minute, and let's just not even put anything there yet. Let's look at constant. It's constant from here to here, right? So it starts at negative 1, and then it goes to what? 4. So do I include negative 1 there? So I can be increasing and constant at the same time? No. So at negative 1, is it increasing or is it constant? Pretty much it's neither. Okay, so we don't include it on either one because you can't include it in both, because then that's saying that it is both and you can't be both at the same time. So when you're talking increasing and decreasing, we don't include it in either one. It's open and open. Okay, those are always open. So then it's decreasing from 4 to where? Is it negative infinity? To infinity. That's where the confusion comes in. Because yes, does y go to negative infinity? Yes, it does. But these intervals you're writing are intervals of the domain. Okay? You're looking at what y is doing. You're writing the x's, right? Observing y, writing x. So let's write that down over here. We are looking for what happens to y as x increases. Right? So that's what x is increasing the whole time. What's happening to y? Right? Is it increasing or decreasing? And then what we're writing are intervals of the domain. We're always writing intervals of the domain. So we're always writing about our x's, but that's talking about our y's. Okay? So let's look at number 5. Now, what type of function is number 5? Absolute value. Okay, it's an absolute value function. You should be able to look at these and recognize the functions and know your parent functions. That's an absolute value function, right? That should be a no-brainer. It's got some transformations happening, but it's an absolute value function. All right, is it increasing anywhere? Yes. So it starts increasing at what? At 3, because remember, we're writing the x's, and it keeps increasing to where? Infinity, right? Okay. And then it's decreasing starting where? Negative infinity to where? 3. Everybody good? Okay, 6. What type of function is 6? It's a rational function. Good. It's a rational function. It's a line that's been blown apart. All right. Is it increasing anywhere? Okay, where's it increasing? X is always increasing, but the function, remember when we talked about function values? The function value is the y. So when you're talking about the function increasing or decreasing, we're looking at the y values. So is there anywhere, as I go from left to right on my domain, is there anywhere where the y is increasing? No, because if I start way out here at negative infinity, as I go along my x-axis, it's decreasing the whole time, right? Then I get to here and it jumps back up here, but that doesn't count as increasing, and then it still continues to decrease. Does that make sense to you? So my increasing intervals, there's none. My decreasing intervals, so can I just write one interval? No. I have to go from negative infinity to where? Is it 5? Negative 5. Okay. Negative 5. Okay, so I think I heard 1, and it's so hard not to write the y's because, like, you see that, and that's where it's split that way. None of this is what you're writing is the y values. Yes, there's like an asymptote here, but we're worried about the vertical one here at 5, because at 5, there's nothing that exists. But then it jumps from here up to here, still decreasing, so then from negative 5, I can't write, negative 5 to infinity once my board catches up. Negative 5 to infinity. No. All right, increasing intervals. Is there anywhere where this is increasing? Yes. So I start out here. Oh, actually, I should have asked this first. What type of function? What function is this? Exponential. Good. So do I have any asymptotes? Yes. How many? Just one. That's important to know, because if you think there's a vertical one also, then that's going to change what your answer would be here, right? But since it's exponential, I have one asymptote, but it's down here. I don't have a vertical one. So my increasing interval then goes from negative infinity to infinity. Decreasing intervals? None. Okay? Questions? All right. What type of function do you think 8 might be? Cubic, maybe. Well, obviously, it is for sure, because I keep forgetting it's actually written up here since we're not. It is cubic, because that kind of gives it away, right? So it is cubic, but even if you didn't have this and all you could see was the function, it looks like what you would recognize as a cubic, right? If you see that shape, it could possibly be one that has a 5 as an exponent, or a 7 it's odd anyway, because they all kind of have the same shape, and then we have to know some other stuff. But yeah, it's a cubic because it gives away for you right there. All right, so then increasing intervals, are there any? Yes, starting at here, 0, and going to 2.5. That sounds good. And then decreasing from negative, what? No, okay. Negative infinity to 0. And then where? 2.5 to infinity. And what do you notice where our breaks are? What are these things? The points that I put in. Your maximum minimums, right? Because that's where it changes direction. We're decreasing, we change direction, we're increasing. We change direction, we're decreasing, right? All right. Increasing anywhere here? Yes. Okay. So my first increasing, we'll say that's negative 2. If you put a point on there big enough, it'll look like it's a negative 2. Negative 2 to 0. And then also 1 to infinity. Okay. And then decreasing starting at negative infinity to negative 2. And then 0 to 1. Okay. And if it makes more sense to you, instead of like doing all your increasing and all your decreasing, then you could do this first interval and put it in your decreasing, and then making sure you start there so that you actually get all of it and you don't miss a chunk in there somewhere. All right, so are there any increasing intervals? Yes, I'm increasing from negative infinity to where? Negative 1. And then where? 1 to infinity. And then, what's this point right here called? Point of inflection. So do I have to split up my decreasing interval? I actually don't. I don't have to split it up because is it still decreasing the whole time? Yes, it's still decreasing the whole time. It's never actually constant. It doesn't go horizontal at all. So this is decreasing the entire time even though there's a point of inflection. So this just goes from -1 to 1 and it's all together. Okay. Any questions at all? We good? All right. So let me hand out your assignment and then I'm going to have you fix something on there. All right, so on the assignment, on the back, it says, give the coordinates and classify the extrema. I want to clarify that really that should say critical points. Because critical points includes the extrema, but it also includes the point of inflection, and I want you to identify that. And then you can mark out the use the graphing calculator, and we're just going to estimate the nearest 0.5 and be good to go for that, okay? And then same thing down here. When you do increasing and decreasing, you can mark out that use your graphing calculator. It's really just kind of a waste of time at this point. Okay, we good? Any questions? Awesome.